Hey guys, welcome back to my channel. Today we're going to do IAL Edexcel International Advanced Level Maths, Pure Maths Paper 3 for January 2024. In this video, we'll discuss all of the topics that can come in Paper 3 and give detailed walkthrough and make sure that you have better understanding for each topic. If you're someone who wants to check out the Paper 1 and Paper 2 videos, you can check it at the link above. Let's start with this video and see how difficult or easy Paper 3 was for this year. So first question is on transformation of functions, and this is something that you already know from your IGCSE because you guys did learn transformation functions and graphs during that time. The point P, -4, -3 lies on the curve with equation y equals to f of x. We have to find the point to which P is mapped when the curve with equation y equals to f of x is transformed to the curve with the equation as given A, B, and C. So for A, it's y equals to f of 2x. So as you remember, if something is being multiplied directly to x, that means you will divide the x value of the coordinate by that number. So for A, your scale factor is going to be 1 over 2, not 2, 1 over 2. So what happens is that we divide -4 by 2, which gives us -2. So only the x coordinate is changing, nothing happens to the y. So P is going to be -2 and -3 remains as it is. Once again, only x is changing, y remains the same. Then after that, the equation is y equals to 3 times f of x minus 1. So now we're multiplying the function by 3, which means the y value is going to change. And for x, we're subtracting 1 from x, which means we're moving the graph 1 unit to the right side, not the left, right. So for x, we're going to add 1 to -4, which gives us -3. And for y, we're going to times -3 by 3, because the scale factor in this case is going to be 3. So P is going to be -3 and -9 for part B. You will transform the x value separately and the y value separately. Then the next one is y equals to the absolute value of f of x. So we're trying to find the modulus of this. So if you know, when you make an absolute value of a function, we're saying that there's going to be no negative value. The result will always be positive. So what happens now is, whatever is negative for y becomes positive. X can be negative. They have put the absolute sign around the function, and the function is the value of y, which means P is going to be now -4 and 3. Once again, only y value is becoming positive, x value remains the same, because the absolute sign is around f of x, not x. So these are your coordinates. Then it says a curve has equation y equals to f of x, where f of x equals to x to the power 4 minus 5x squared plus 4x minus 7. Show that the equation f of x equals to 0 has a root alpha in the interval 2 to 3. So in this one, in order to find out whether there's a root between a given interval, you need to see if the sign is changing for the f of x value. Why? Because if you draw a graph, root is basically your x-intercept. So if I draw a graph like this, just a random graph, so over here, these are our roots. So above the x-axis, we know y is positive, whereas below the x-axis, y is negative. So in between this positive and negative is the x-axis where we're intercepting, and that point is your root. So if your sign is changing for the f of x values, that means there's a root in between those two values of x. So let's check that over here. So we have f of x equals to x to the power of 4 minus 5x squared plus 4x minus 7. So at x equals to 2, our function is going to have a value of 16 minus 20 plus 8 minus 7, and that is negative 3. Now at x equals to 3, it's going to be 3 to the power 4 minus 5 times 3 squared plus 4 times 3 minus 7. So that's going to be 81 minus 45 plus 12 minus 7. That's 41. So at x equals to 2, the function has a negative value. At x equals to 3, the function has a positive value, which means in between, the graph crossed the x-axis. So since the signs are changing, there is a root between these two values. So f of x is less than 0 at 2, and at 3, it's greater than 0. Since the sign of f of x is changing, it means there is a root in the given interval. That is your answer for part A. Then it's stating that show that the equation f of x equals to 0 can be written as x equals to cube root of 5x squared minus 4x plus 7 divided by x. So what we'll do now is, so the equation is 0 equals to x to the power of 4 minus 5x squared plus 4x plus 7. I'm going to move 5x squared plus 4x plus 7 to the other side. That equals to x to the power 4. Now we know that there was a cube root over here. So what we will do is we'll split the x to the power 4 into x cubed times x. Now we'll divide 5x squared minus 4x minus 7 by x. That equals to x cubed. Now we will cube root both sides. So it's going to be cube root of 5x squared minus 4x minus 7 over x equals to x. That is the same as the equation given in the question. Then the iterative formula is xn plus 1 equals to cube root of 5xn square minus 4xn plus 7 divided by xn. It's used to find alpha. Starting with x1 equals to 2 and using the iterative formula, we have to find to 4 decimal places the value of x2 and to 4 decimal places the value of alpha. So since they've given us the value of x1, so x2 is going to be cube root of 5 x1 squared minus 4x1 minus 7 over x1. So replace x1 with 2. Which gives us 2.1179. That is your answer correct to 4 decimal places. Then so to figure out the value of alpha, what we'll do is we'll keep on substituting values in the iterative formula till we have the same value for each thing. So for example, we have x2 right now. So what I'm going to do is I'm going to use that to find x3. So x3 is going to be cube root of 5 times 2.1179 minus 4 times 2.1179 minus 7 divided by 2.1179. That's going to give us a value of 2.146846021. Now we're going to repeat this step again. So we find x4. So for that, again, plug it in the calculator. So that's going to give you 2.154063147. We're putting x cubed in the formula we're putting x3 in the formula to find x4. Then for x5, we're going to put x squared in the formula. So that's going to give us 2.155 869187. Then I'm going to repeat it again by putting x5 in the formula to get x6, which is going to be 2.156321484. Again repeated, x7 is going to be 2.156434777. Again, x8 is going to be 2.156463157. The reason why we're repeating this process is we're going to make sure that the value is going to be the same like after some time. So if you notice, I'll see the 9 value as well. So that's going to be 2.156470266. We have to give the answer correct to 4 decimal places. So for 4 decimal places, this is 4 decimal place, this is 4 decimal place, 4 decimal place. So for 4 decimal places, we can see that after divided, it's going to be 2.1564 for x7, x8, and x9. So based on that, if we round this, it's going to be 2.1565 because this is going to round to 2.1565. This is going to round to 2.1565. And so is the next one going to round to that. So we know that this is going to get repeated every single time. Hence, that is the value of alpha. This is the amount of money raised for charities being monitored. The total amount raised in the T months after monitoring began is D pounds and is modeled by the equation log D to the base of 10 equals to 1.04 plus 0.38 T. We have to write this equation in the form of D equals to A times B to the power of T, where A and B are constants to be found, giving each value to 4 significant figures. So for this, the equation is log of D to the base of 10 equals to 1.04 plus 0.38 T. So what we'll do is we will rewrite this as an exponent. We know if it's like log of 10b, let's say, equal to a. So this becomes 10 to the power of a equals to b. So keeping this rule in mind, we're going to rewrite this as d equals to 10 to the power of 1.04 plus 0.38t. This is all in the power. So now when you split it, it's going to be 10 to the power of 1.04 times 10 to the power of 0.38t. If you remember from your IGCSE, one of the rules of indices is that when we're multiplying similar bases, we add the powers. So now we're splitting the base into 2 bases, which are being multiplied, and the powers are separate now. Which means A is going to be 10 to the power of 1.04. Because if we go back to the question, it's A times B to the power of T. So A is 10 to the power of 1.04 and B is going to be 10 to the power of 0.38. So this is your value of A and B. I'm not writing the T because the T exists separately on both the B's, so I think it should be fine like this. Like they shouldn't deduct marks for that. So I have to give each value for A and B correct to 4 significant figures. So that's going to be 10.96 and B is going to be 2.399. These are your values correct to 4 significant figures. Then when T equals to capital T, the total amount of money raised is 45,000 pounds. According to the model, find the value of capital T, giving your answer correct to 3 significant figures. So D represents the total amount of money being raised. So our equation is going to be 45,000 equals to 10.96 because it's D equals to A times B to the power of T times 2.399 to the power of T. So 45,000 divided by 10.96 equals to 3.99 to the power of T. That's going to give us a value of 4104.34 equals to 2.399 to the power of t. Now, since the power has the variable, so to bring that variable down, we have to take logs on both sides. You can take ln or lg, both will give you the same answer. But it has to be the same thing on both sides. You cannot take ln on one side and log on one side. So you have to be careful about that. So the t comes down now because, in logs, we can bring the power down and write it as the coefficient, which is something you learned in differentiation as well. But like in that, obviously subtracting 1 from the power as well. You don't subtract anything from the power. You just bring the power down for a log and it becomes the coefficient. Now we can just write log of 4104.34 divided by log of 2.399 equals to t. So that's going to give t as 9.51. That is your value of t. Then says the charity aims to raise a total of £350,000 within the first 12 months of monitoring. According to the model, determine whether or not the charity will achieve its aim. So there are two ways of doing this. Either you find if they're getting the same value, or you put it equal to the given value and then see whether both sides are going to be equal or not. So if we do that, we're saying that the equation will equal to 350,000. And we have to see whether we're getting a value of 6 for t or not. So first, we're going to divide 350,000 by 10.96, which gives us a value of 31,934.31. After that, what we're going to do is we're going to put logs on both sides, like we did in the previous part, so that we can bring the variable down. This is comma, not decimal. So t times log of 2.399. Now we divide the two. And that gives you a value of 11.85 for d. And we can round that to 12. So that's exactly what the question was asking. And we've proved that in 12 months. Is that what it is? Yeah, in 12 months, we're raising £350,000. That's your answer. Then it says the function f is defined by f of x equals to 2x squared minus 32 over 3x squared plus 7x minus 20 plus 8 over 3x minus 5, where x contains all real numbers and x is greater than 2. We have to show that f of x is equal to 2x over 3x minus 5. So again, this is like a continuation of what you learned in IGCSE in simplifying algebraic fractions. You have to simplify this algebraic fraction, which has fractions being added and the denominators are different. So to simplify it, we would first factorize both the fractions separately and then, solve it in a combined manner. So what we will do first is that I'll factorize the quadratic equations in the first fraction. Let's start with that. So f of x equals to 2x squared minus 32 over 3x squared plus 7x minus 20 plus 8 over 3x minus 5. So in the numerator, we can take 2 common first. So x squared minus 16 in the bracket. The denominator, we can solve it by splitting the middle term. 3 times 20 is 60. Factor of 60, which we can use to replace 7, is 12 and 5. So 3x squared plus 12x minus 5x minus 20 plus 8 over 3x minus 5 comes as it is. Now we know we have two perfect squares being subtracted, so we can use difference of perfect squares, which splits this into x minus 4 times x plus 4. By now, you should be able to identify like which type of factorization method you need to use based on the given quadratic equation. And over here, we use factor by grouping. We'll split the equation to two groups. In the first group, we have 3x common. X plus 4 comes in the bracket. In the second group, we have negative 5 common. X plus 4 comes in the bracket. Now, in the denominator, what we'll do is we'll take x plus 4 common, and in the other bracket, we'll have 3x minus 5. So we can simply cancel out x plus 4 because they're being multiplied in the numerator and denominator and they're being divided by each other. And then we have 2 bracket x minus 4 over 3x minus 5, and then plus 8 over 3x minus 5. The denominators are exactly the same, so we can rewrite it as a single fraction and combine the numerators. 2 times x is 2x, 2 times negative 4, negative 8, plus 8 comes as it is, and that is equal to 2x over 3x minus 5, as mentioned initially in the question. Yep, so the same thing. Then show using calculus that f is a decreasing function. You must make your reasoning clear. So to show that f is a decreasing function, we're going to differentiate this first. So f of x is 2x over 3x minus 5. I'm going to use the quotient rule over here, which says that the numerator is going to be u and denominator is going to be v. We're going to differentiate u and v separately first. So that's 2, and this is going to be 3. Now, according to the quotient rule, dy by dx equals to u derivative times v minus v derivative times u over v squared. This is the formula that we follow for quotient rule. So u derivative is 2, so 2 times 3x minus 5 minus 3 bracket 2x over 3x minus 5 squared. That's going to be 6x minus 10 minus 6x over 3x minus 5 squared, which is negative 10 over 3x minus 5 squared. This is our first derivative. In the question, if you notice, this said that x is greater than 2. So for x greater than 2, f derivative x is going to be at 2, sorry. That's going to be negative 10 over 3 times 2 minus 5 squared, which is negative 10 over 1, and that's negative 10. Since it's negative, that means it is decreasing. For any value of 2 and more, it's going to keep on decreasing. It's not going to increase. Because the numerator is negative, it's going to stay negative, and the denominator is getting squared. So if you square a positive number, it's going to be positive. If you square a negative number, it's still going to be positive. So nothing will change it because the numerator is fixed at a negative value. Then it says that the function g is defined by g of x equals to 3 plus 2 ln x, where x is greater than or equal to 1. We have to find the inverse and then find the exact value of a for where g of f a equals to 5. Okay, so let's start with finding the inverse first. G of x is 3 plus 2 ln x. So y equals to 3 plus 2 ln x. Make x the subject, so y minus 3 equals to 2 ln x. Y minus 3 divided by 2 equals to ln x. If you want to remove ln on one side, you add e on the other side. So it becomes e to the power of y minus 3 over 2 equals to x. So g inverse of x is e to the power of x minus 3 over 2. That is your inverse function. And for the domain of the inverse, if we go back to the question has clearly stated that the domain of the original function is x is greater than equal to 1. So g of 1 is 3 plus 2 ln 1. ln 1 is 0, so at x equals to 1, the function is equal to 3. So as you remember from your IGCSE, the domain and range of original function will be the opposite for the inverse. So whatever is the domain of g, that's going to be the range of the inverse of g. And whatever is the range for g is going to be the domain for the inverse of g. Hence, over here in this case, your x value is going to be greater than equal to 3. That is the domain of the inverse. After this, we had to find the composite function g of f of a equals to 5 and find the value of a. Let's find f of a first. So 2a over 3a minus 5. So g of f of a is going to be, we're going to replace the x in g with 2a over 3a minus 5. So 3 plus 2 ln of 2a over 3a minus 5. So this equals to 5. That's 5 minus 3 equals to 2 ln 2a over 3a minus 5. 2 over 2 equals to ln of 2a over 3a minus 5. So that's 1. And then we replace ln with e on the other side. So it's e to the power of 1 equals to 2a over 3a minus 5. Now we solve it in terms of e. Cross multiply e times 3a minus 5. They're asking us to find the value of a. So our goal is to make a the subject. So 3ae minus 5e equals to 2a. Collect the terms with a on one side so that we can take a common. So a bracket 3e minus 2 equals to 5e. So a is going to be 5e divided by 3e minus 2. That is your value of a. And that's your answer for part D. Then the next question says, in this question, you must show all stages of your working. Solutions relying entirely on calculated technology are not acceptable. So the temperature T degrees Celsius of the air in a room T minutes after heat source is switched off is modeled by the equation T equals to 10 plus A times e to the power of negative B times T, where A and B are constants. Given the temperature of the air in the room at the instant that the heat source was switched off was 18 degrees Celsius, we have to find the value of A. Okay, so for this, T equals to 10 plus A times e to the power of negative B times T. T is given as 18 because that is the temperature once the heat source was switched off. And what we know is that small t, which is the minutes, is going to be 0. That's like the time that has spent after the heat source was switched off, and they're saying at the instant the heat source was switched off. So the moment the heat source is switched off, t is 0. No time has been spent. So small t is going to be 0. Capital T is 18. So 18 equals to 10 plus a times e to the power of negative b times 0. E to the power of 0 is going to be 1. So 18 minus 10 equals to a, and a is 8. Then it says that given also that exactly 45 minutes after the heat source was switched off, so this is your small t value. The temperature of the air in the room was 16 degrees Celsius. This is your capital T value. You have to find the value of B to 3 significant figures. So now it's going to be 16 equals to 10 plus 8 times E above negative B times 45. 16 minus 10 divided by 8 equals to E to the power of negative 45B. So that's going to be 6 out of 8. To remove the E, we'll put ln on both sides. So ln 6 over 8. Over here, ln E to the power of negative 45B. We bring the power down. As we know, we can do that in logs. And ln E has the value of 1. So it becomes ln 6 over 8 equals to negative 45B. So ln 6 over 8 divided by negative 45 gives us a value of 0.00639 for B. Then using the values for A and B, find, according to the model, the rate of change of the temperature of the air in the room exactly 2 minutes after the heat source was switched off. So this is small t. So now we have to find capital T. We have A, we have B, we have small t. So they want us to find the rate of change of the temperature, which means we have to differentiate our temperature equation, then substitute the value of T equals to 2 in it to get the rate of change at that point. So firstly, capital T equals to 10 plus A to the power of times e to the power of negative 0.00639 t. Differentiate capital T with respect to the small t. Capital T is temperature, small t is your time. So that's going to be 8 times negative 0.00639 times e to the power of negative 0.00639 t. An exponential function, e remains as it is, but you differentiate the power and multiply the derivative of the power with the exponential function. So now you find the value of this at t equals to 2. So dt by dt is going to be 8 times negative 0.00639 times e to the power of negative 0.00639 times 2. That's going to give us a value of negative 0.0505. That is your answer. Then D equals explain why, according to the model, the temperature of the air in the room cannot fall to 5 degrees Celsius. So it cannot fall below 5 degrees Celsius because if you go back to the equation, so it cannot fall to 5 degrees Celsius because if you write the equation, 5 equals to 10 plus 8 times e to the power of negative 0.00639 t. So we do 5 minus 10 divided by 8 equals to e to the power of negative 0.00639 t. So that's going to be negative 5 over 8. And as you know, when you replace the e over here with ln, we can't take log of a negative number. So that is exactly why it cannot be 5, or even like it cannot be a number that's going to give us a negative value. So that's why it cannot be a negative number. That's why it cannot be 5, because we can't take the log of a negative number. I'm going to complete the steps over as well so that you understand what I'm saying. 639t. So then ln negative 5 over 8 equals to negative 0.00639t. So this is not possible. That's why it can't be 5. Then it says, in this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. Figure 1 shows a sketch of the curve with the equation y equals to f of x, where f of x is 2 times e to the power of 3 sine x, then times cos x, where x is between 0 and 2 pi. The curve intersects the x-axis at point R, as shown on figure 1. You have to state the coordinates of R. So we'll put f of x equals to 0 for this because it's an x-intercept. So 0 equals to 2e to the power of 3 sine x times cos x. So we're going to divide 0 by 2e to the power of 3 sine x, which gives us 0. So 0 equals to cos x. So cos inverse of 0 is going to give us pi by 2 because it's a cos function. So cos is equal to 0 at pi by 2 and 3 pi by 2. Over here, since r is over here, it's going to be 3 pi by 2, not pi by 2. So r is going to be 3 pi by 2 and y is 0. That's your coordinate for r. Then the curve has two turning points at point P and point Q, also shown in figure 1. Show that at points P and Q, a sine squared x plus b sine x plus c equals to 0, where a, b, and c are integers to be found. So what we're going to do over here is that we're going to differentiate it. Why? Because to find the turning points, you have to find the derivative. Because when we put the derivative equal to 0, that gives you the x values of the turning points. So f of x is 2 times e to the power of 3 sine x times cos x. So for this, I'm going to use the product rule for differentiation because we have two functions being multiplied. So I'm going to say that u equals to 2 times e to the power of 3 sine x and v equals to cos x. So u derivative is going to be 2 times the derivative of the power of e, which is going to be 3 cos x, because derivative of sine x is cos x, and then e comes as it is with its power. And for v, the derivative of cos x is negative sine x. For these type of questions, you need to know your basic derivatives of the trigonometric functions and exponential functions. So that gives us 6 cos x times e to the power of 3 sine x. Now, the product rule for differentiation is that f dash x is going to be u derivative v plus v derivative times u. So u derivative is 6 cos x times e to the power of 3 sine x times cos x plus negative sine x times 2e to the power of 3 sine x. That's going to be 6 cos square x times e to the power of 3 sine x minus 2 sine x. That's going to be times e to the power of 3 sine x. Now we can replace the cos square x with 1 minus sine square x because if I'm not wrong, the question is in terms of sine. Yeah. So 6 bracket 1 minus sine square x times e to the power of 3 sine x minus 2 sine x times e to the power of 3 sine x. 6 times e to the power of 3 sine x minus 6 sine square x times e to the power of 3 sine x minus 2 sine x times e to the power of 3 sine x. And all of this is going to equal to 0 because trying to find the turning point, so the derivative equals to 0. So you can take e to the power of 3 sine x common. So that's going to be 6 minus 6 sine square x minus 2 sine x. So 0 equals to 6 minus 6 sine square x minus 2 sine x. Make that positive. So 6 sine square x plus 2 sine x minus 6 equals to 0. That is your equation in terms of sine. Then, hence find the x coordinate of point. You're giving an answer to 3 decimal places. So we're going to solve this quadratic equation. So I'm going to assume that sine x equals to a. That's going to make my equation much simpler to understand. So 6a squared plus 2a minus 6. Since in the question it said decimal places, that means we cannot use splitting the middle term, so we'll directly use the quadratic formula. So a equals to minus 2 plus minus root of 2 squared minus 4 times 6 times negative 6 over 2 times 6. That's going to give us a value of negative 2 plus minus root of 148 over 12. So one value of a is going to be 0.84712 and the other value is going to be negative 1.1804. Obviously, we cannot take sign of a negative number. So this is going to be not applicable, and I'm just going to use a equals to 0.84172. So sine x is equal to a, like we said. So sine x equal to 0.84712. X is sine inverse of this. And that is equal to 1.011. If we look at the diagram, Q is in the second quadrant from 90 to 181. So if you notice, Q is in the second quadrant from 90 to 180. So I'm going to subtract 1.011 from pi to get the value of Q. So 1.011 over here and 1.011 over here. So x is going to be pi minus 1.011, which gives us a value of 2.131. So they're asking for the x coordinate of Q, so this is your answer. Then it says, in this question, you must show all stages of your working. Solutions relying entirely on calculation technology are not acceptable. So curve C has equation y equals to 16 over 9 times 3x minus k. where x does not equal to k over 3. K is a positive constant not equal to 3. We have to find dy by dx given constant in simplest form in terms of k first. So let's find the first derivative. Your y value equals to 16 over 9 times 3x minus k. So we can rewrite this as 16 over 9 times 3x minus k to the power of negative 1. I'm bringing it in the numerator so the power of the bracket becomes negative. So dy by dx is, so it's going to be 16 over 9 times negative 1, you bring the power down, then 3x minus k minus 1, and then the derivative of 3x, which is 3. So that's going to be negative 16 over 3 times 3x minus k whole power negative 2. You can rewrite this as negative 16 over 3 times 3x minus k whole square. Then it says the point P with x coordinate 1 lies on C, given that the gradient of the curve at P is negative 12. Find two possible values of k. We have the gradient, we have the x value, so the only unknown is k. Negative 12 equals to negative 16 over 3 times 1 minus k whole square. Negative 12 times 3 equals to negative 16 over 3 minus k whole square. Negative 36 times 3 minus k whole square equals to negative 16. So 3 minus k whole square equals to negative 16 divided by negative 36. Negative gets cancelled out. And 16 over 36 becomes 4 over 9. Square root both sides. So 3 minus k equals to plus minus 2 over 3. So 3 minus k equals to 2 over 3. 3 minus k equals to negative 2 over 3. So 3 minus 2 over 3 equals to k. And 3 plus 2 over 3 equals to k. So 9 minus 2, 7 over 3. And the other one is going to be 11 over 3. These are the two values of k. Given also that k is less than 3, find an equation of the normal to C at P, writing your answer in the form of ax plus by plus c equals to 0, where a, b, and c are integers to be found. K is less than 3, which means k equals to 7 over 3. So, since we're talking about the normal, dy by dx is going to be negative 16 over 3 times 3 times 1. X is going to be the same because we're still talking about point P. We're going to put in the value of k and find the value of dy by dx. That's going to give us negative 12. So since it's a normal, that means we do m1 times m2 equals to negative 1 because the normal and the curve are at right angles to each other. So negative 12 times m2 equals to negative 1. m2 equals to 1 over 12. For the y value, we put x equals to 1 into the original function. So y equals to 16 over 9 times 3 times 1 minus 7 over 3 because k is 7 over 3. That gives us a value of 8 over 3. So P is 1 and 8 over 3, and M is 1 over 12. Now let's use this to find the equation. Y minus 8 over 3 equals to 1 over 12 times x minus 1. 3y minus 8 over 3 equals to x minus 1 over 12. Cross multiply, so 12 divided by 3 is 4. So 4 times 3y minus 8 equals to x minus 1. 12y minus 32 equals to x minus 1. 12y minus x minus 32 plus 1 equals to 0. So that gives us 12y minus x minus 31 as the equation of the normal based on the format they were asking for. Then show using algebraic integration that the integral of 16 over 9 times 3x minus k from the limit of 1 to 3 is the same as lambda times ln 10, where lambda is a constant to be found. So what we're going to do is, first let's replace the values. So 16 over 9 times 3x minus 7 over 3 dx. We're going to integrate this. So we have to take the 16 over 9 outside. So it's the integral of 1 over 3x minus 7 over 3 dx. So if you remember, when we have a bracket in the denominator and its power is 1, we integrate it using logs. So this will become ln of 3x minus 7 over 3, and then we will divide this by the derivative of the bracket. So derivative of 3x minus 7 over 3 is 3. So it becomes divided by 3. This is your integral. Once again, if there's a bracket in the denominator and the bracket has power of 1, we will use ln to integrate it. So it becomes ln of 3x minus 7 over 3. And then we divide it by the derivative of like the expression in the bracket. So derivative of 3x minus 7 over 3 is 3. So we divide by 3. So if we bring the 3 outside as well, it's going to be 16 over 27 times ln of 3x minus 7 over 3. Let's make it simpler. If you want to keep it inside, that's also fine. If you want to keep the 1 over 3 inside, you can also do that. If you want to take it outside, that's also fine. So it's going to be 16 over 27 times ln of 3 times 3 minus 7 over 3 minus ln of 3 times 1 minus 7 over 3. So that's going to give us a value of 16 over 27 times ln of 20 over 3 minus ln of 2 over 3 is going to equal to ln of 20 over 3 divided by 2 over 3. Since two ln's were being subtracted, we can combine it as a single ln by dividing the numbers. So 20 over 3 divided by 2 over 3, which is going to give us ln of 10. So 16 over 27 times ln 10. Lambda is going to be 16 over 27, and ln 10 is exactly the same as what was given the question. So that's your answer. Then in this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable again. So the graph shown in figure 2 has equation y equals to a minus the absolute value of 2x minus b, where a and b are positive constants and a is greater than b. Find, giving your answer in terms of a and b, the coordinates of the maximum point of the curve, of the graph. So for the maximum point, it's going to be b over 2 and a. Why? Because if you remember completing square form, y equals to a times x minus h whole square plus k. H and k were your coordinates of the maximum point or the minimum point, depending on how the graph looked like. So over here, for h, it's going to be b over 2, and for k, it's going to be a. So we're following the exact same pattern, but like the equation looks different because it's an absolute function now. Then the coordinates of the point of intersection of the graph with the y-axis, which means x is going to be 0. So at x equals to 0, y is going to be a minus 2 times 0 minus b, a minus absolute value of negative b, which will make it positive, so a minus b. So your coordinates are going to be x is 0 and y is a minus b. Then the coordinates of the points of intersection of the graph with the x-axis, so now y is going to be 0. So 0 equals to a minus 2x minus b. Absolute value of 2x minus b equals to a. So when we remove the modulus, 2x minus b equals to positive a and 2x minus b equals to negative a. We have two different equations. So x is going to be a plus b over 2, and x is going to be, this is negative, sorry, negative a plus b over 2. So your two coordinates are going to be a plus b over 2, 0, and negative a plus b over 2, 0. On page 24, there's a copy of figure 2 called diagram 1. On diagram 1, sketch the graph with the equation y equals to absolute value of x minus 1. So page 24. So absolute value of x minus 1 is going to be this. This point is going to be negative 1. This is your sketch. Just move y equals to absolute value of x 1 unit down because there's a vertical translation happening. Then given that the graph of y equals to absolute value of x minus 1 and y equals to a minus absolute value of 2x minus b intersect at x equals to negative 3 and x equals to 5, you have to find the value of a and the value of b. Over here, this will play a very important role, that a is greater than b. So they're both intersecting at x equals to negative 3 and 5. This is part B. Y equals to absolute value of x minus 1 and y equals to a minus absolute value of 2x minus b. So absolute value of x minus 1 equals to a minus absolute value of 2x minus b. So one equation can be positive x minus 1 equals to a minus positive this 2x minus b. So that becomes x minus 1 equals to a minus 2x plus b. When we remove the modulus sign, we get a positive and a negative value. So one equation is going to be with the positive ones. So that's x minus 1 plus 2x equals to a plus b, which is 3x minus 1 equals to a plus b. That is one equation. Then the other one is going to be with negative values. So it's going to be negative x minus 1 equals to a minus negative 2x plus b. So negative x minus 1 equals to a plus 2x minus b. That is the second equation. So negative x minus 1 minus 2x equals to a minus b, which is negative 1 minus 3x equals to a minus b. Now x was given as negative 3 and 5. Add x equals to negative 3 and add x equals to 5. So what we'll do is we'll put x equals to negative 3 in the negative equation and x equals to 5 in the positive equation. Because the intersection is based on the sign as well. One side is negative and the other is positive. So for x equals negative 3, our equation is going to be negative 1 minus 3x equals to a minus b. Negative 1 minus 3 times negative 3 equals to a minus b. Negative 1 plus 9 equals to a minus b. 8 equals to a minus b. For the other one, we'll use the positive equation, like I said, so it's going to be 3x minus 1 equals to a plus b. So 3 times 5 minus 1 equals to a plus b, which is 14 equals to a plus b. Now we solve these two simultaneously. We can cancel out the b, add the value. So 8 plus 14 is 22. This is 2a. 11 is the value for a. So b is going to be a minus 8. I'm going to pick this equation. So 11 minus 8, and that is 3. So a is 11 and b is 3. These are the values of a and b. Then this question, you must show all stages of your working. Solutions relying on calculator technology again are not acceptable. So trigonometry, it says that show that the equation 3 sine theta cos theta over cos theta plus sine theta equals to 2 plus secant 2 theta times cos theta minus sine theta can be written in the form of 3 sine 2 theta minus 4 cos 2 theta equals to 2. So this is going to be about double angle identities. This is something you haven't done before in your IG. So slightly different concept, and for this you need to learn your identities. So we're going to start with writing the equation first. For this type of question, you need to know how to identify which identity to use and when. So firstly, one identity is that 2 sine theta cos theta equals to sine 2 theta. But since there's no 2 being multiplied over here, so we're going to write half of sine 2 theta. Where there's a 3 over, I forgot that. So sine theta cos theta, like twice of this equals to sine 2 theta. But since we only have sine theta cos theta, so it becomes sine theta cos theta equals to half of sine 2 theta. So the numerator gets replaced by 3 times sine 2 theta over 2. And we cross multiply the cos theta plus sine theta to the other side. So 3 over 2 sine 2 theta equals to 2 plus secant 2 theta times cos theta minus sine theta, and then again cos theta plus sine theta. we can rewrite cos theta minus sine theta times cos theta plus sine theta using difference of perfect squares. So it becomes cos square theta minus sine square theta. Now we're going to use another identity over here. Cos square theta minus sine square theta, let me write that over here, is basically the same as cos 2 theta. This is again another identity. So we're going to replace the bracket with cos 2 theta. So 3 over 2 sine 2 theta equals to 2 plus secant 2 theta times cos of 2 theta. Now, the next step is going to be to rewrite secant 2 theta as 1 over cos 2 theta because secant theta is 1 over cos theta. So secant 2 theta is going to be 1 over cos 2 theta. So 3 over 2 sine 2 theta equals to 2 plus 1 over cos 2 theta times cos 2 theta. Now we expand the bracket. So it's going to be 2 cos 2 theta plus 1. Cos 2 theta times 2 is 2 cos 2 theta. Cos 2 theta times 1 over cos 2 theta is 1. So now again cross multiply to get rid of the fraction. So 3 sine 2 theta equals to 6 cos 2 theta plus 3. So 3 sine 2 theta minus 6 cos 2 theta equals to 3. I think that is, there's a 4. Sorry, this is 4. 2 times 2 is 4, not 3. Yeah, so this is your equation. Next, they're saying that, then it says, hence solve for x is from pi to 3 pi by 2, where we have the first equation, and we have to solve it giving the answer correct to 3 significant figures. Since it's saying hence, that means we will use this equation. Always. Hence means that use your answer from the previous part. So to use this, we use another form of method where you know that r times sine of x plus minus alpha, alpha being the angle, equals to a sine x plus minus b cos x. Since we have minus, so r sine x minus alpha equals to a sine x minus b cos x. R is your root of a square plus b square. Our equation is 3 sine 2 theta minus 4 cos 2 theta equals to 2. So a is 3, b is 4. R is going to be 3 square plus 4 square, which gives us a value of 5. For the value of alpha, what we do is we expand the left-hand side. So 3 sine of x minus alpha. That is basically 3 sine x times cos alpha minus 3 cos x times sine alpha. That is the expansion for this. So this part is equal to this, which is equal to this. So what we're going to do is we're going to write a sine x minus b sine x over here, which is equal to r sine x cos alpha minus r cos x sine alpha. So r cos alpha equals to A and R sine alpha equals to B. This is supposed to be cos, not sine. This is cos X. Okay, so R cos alpha is equal to A and R sine alpha is equal to B. So A value is 3, B value is 4. So tan alpha is equal to R sine alpha over R cos alpha, which means tan alpha is going to equal to 4 over 3. We use this to find the value of alpha. Alpha equals to tan inverse of 4 over 3, and that's going to give us a value of 0.927. Whenever you get such a question, these are your fixed steps. You have to do all of these to figure out the value of R, to figure out the value of alpha, then put them back into the equation to find the values of X as asked in the question. So now the equation is 5 sine of 2x minus 0.927 equals to 2. This is the equation we're going to solve. We have our R value, which is 5. We have our alpha value, which is 0.927. And they are told us that the equation equals to 2. So we removed the 3 sine 2 theta minus 4 cos 2 theta and replaced it with 2 because that's what it equals to. So sine of this equals to 2 or 5. 2x minus 0.927 equals to sine inverse of 2 over 5. That gives us a value of 0.4115. Now sine is positive over here and over here. But since it's a double angle, we're going to add 2 pi to our values. So our values of 2x minus 0.927 are going to be 0.4115. Then pi minus 0.4115. Then 2 pi plus 0.4115. And then 2 pi plus the second value, pi minus 0.4115. All of these are going to give us values of 2.730, 6.695, and 9.013. Then we add 0.927 to all of them, and after that we divide them by 2 to get the value of X. So X is going to be 0.66925 for the first one. Once we add it with 0.927 divided by 2, then we're going to have 1.8285, then 3.811, and then 4.97. So if we go back to our limit, it says it has to be between pi and 3 pi by 2. So the value that's going to be between pi and 3 pi by 2 is not the first two values because they're all less than pi. And 3 pi by 2 gives us a value of 9.42. So obviously this is going to be, since 3 pi by 2 is equal to 4.712, so 3.811 is the only value that's between the given limit. So x is equal to 3.811. That is your final answer. And with that, we're done with this paper. If you have any questions or confusions, please leave a comment below and I'll help you out. If you understood everything, please like and subscribe, share this video with your friends, and don't forget to check out the other videos in this playlist.